Esther Trufan, and in this experiment, I'm going to demonstrate how we standardize our sodium hydroxide solution with a stable acid like KHP or potassium hydrogen phthalate. For this experiment, we are going to start with a known mass of the KHP or potassium hydrogen phthalate, and we are going to titrate it with our prepared sodium hydroxide solution that we already used to charge our Buret. So to get started, we're going to need some chemicals. The first is going to be our KHP. We will dissolve it in deionized water. And because KHP is a white solid that will turn into a colorless solution, and the sodium hydroxide is also a colorless solution, and the resulting product of these two reacting will also be a colorless solution, the only way to monitor any changes in the pH will be to use an indicator. And for today, that will be phenolphthalein. We only need a couple drops of this one. For the sodium hydroxide solution, we need it in a Buret that is fully charged and ready for a titration. Here we have our Buret that is held by the Buret clamp, and we already recorded its starting volume, but we will record again once we begin our titration. Next, because we need to know the exact amount of KHP that we are working with, we will need a scale and a weighing boat. And then to measure an approximate amount of deionized water into the solution, to dissolve the KHP, we will need a graduated cylinder. And then to contain our analyte mixture, we're going to use an Erlenmeyer flask. So to begin, we're going to first measure out 0.5 grams of our KHP. We turn on the scale, place the weighing boat on top of it, tare, and add 0.5 grams of the potassium hydrogen phthalate. It is okay to go a little bit above or below. In my case, it is a little above at 0.51 grams. And with that, I am done with the KHP and the scale. I will transfer the contents of my weighing boat into the Erlenmeyer. And then measure out in a 50 milliliter graduated cylinder anywhere between 25 and 30 milliliters of deionized water. I have 26.9 milliliters of deionized water. And first, I'm going to pour some onto my weighing boat. Swirl it around just a little bit to make sure I dissolve any KHP residue and transfer it inside the Erlenmeyer. I will do this twice with small increments of the deionized water. When done, I can discard of the weighing boat. And now I need to make sure that my KHP is fully dissolved in the deionized water. If it doesn't dissolve with the original amount of water, we can add more. My KHP is fully dissolved, so I am done with my deionized water and my graduated cylinder. Next, I'm going to add 2 drops of my phenolphthalein indicator. And that is it. Now I'm going to bring in my Buret that has been charged with the 0.1 molar sodium hydroxide solution. And the first thing I'm going to do is record my starting volume. As in every other circumstance, I'm not going to climb on lab furniture. I am going to lower the Buret to my eye level. And in this case, at my eye level, I should see the meniscus of my sodium hydroxide solution. And in this case, it is 0.36 milliliters. I will raise it up and move it to the side. All right. Where it goes from here is completely dependent on your handedness. I am right-handed, and therefore I prefer to do the swirling of the solution with my right hand and to release the sodium hydroxide amounts with my left. So for me, that means that I'm going to turn this around. And I will orient my stopcock to face my left hand. My right hand is going to swirl the Erlenmeyer. I need to place it right under at a comfortable level. If this is a little too low, I need to raise the Buret. If it's too high, I need to lower it. I will raise it just a little bit higher. This way, I know I will not accidentally bump into the bottom of the stand. Because what we are going to see during the titration is a color change, sometimes the bottom of our stand or the top of our countertop is not going to make it easy for us to see any color changes. So in those instances, it will help us to add a white paper right under it, so even the slightest color change can be detected. And that's what I'm going to do now. Here is a piece of white paper. I will slide it under my Erlenmeyer. And now, whatever color change appears, I should be able to detect it. And now we are ready to begin. The process is straightforward. I will open the stopcock at its fully open position and swirl it, not terribly vigorously, but somewhat vigorously. When the magenta color begins to appear, then I will begin slowing down a little bit. The magenta color is becoming a little bit more persistent here. So this is where we slow down to almost dropwise additions. And this is where any time spent on gaining control of your Buret is going to pay off. If upon gentle swirling, your magenta color completely disappears, you are not at the end point of your titration yet. This is the right color. It is barely pink, pink purple, or magenta, which is the right shade for what we're looking for. So at this point, we can consider our titration to be at the end point. And we can say our KHP has been fully neutralized by the 0.5 molar sodium hydroxide solution that was added to it. The next step is to collect the final volume of the sodium hydroxide solution we used to achieve neutralization. And that is going to be 27.93 milliliters. From the end volume minus the starting volume that we recorded earlier in the experiment, we will determine the volume of sodium hydroxide solution that was added to our KHP solution that we had at the beginning. From those two amounts, because the only certain one is the mass of the KHP, we should be able to determine the concentration of our sodium hydroxide solution. One titration is never enough to draw conclusions, so we need to repeat this experiment at least 2 more times. And we need to record the average of those concentrations for the sodium hydroxide as our final standardized sodium hydroxide molarity.